In this video, I'm going to be modeling for you some of the concepts that we have been talking about recently with patterns. So there's a couple of different kind of big vocabulary words that we use with patterns. So first of all, a pattern is something that you notice happening over and over and over again, a rule that is happening, and it can happen with shapes or numbers. Or that word geometric, so they should think shapes or symbols, and numerical is with numbers and operations. And some fourth graders right away said, well, what does this have to do with math? Like they could see how the numerical did because it's numbers, but they were kind of wondering about the geometric. And so I explained to them that math is all about patterns. Like even when you're adding and subtracting, there's rules that happen over and over and over again. Like when you are always joining numbers and you get to 10 of something, you're always going to go to that next place value. That's considered a pattern. And so just having them recognize those, or even in their daily lives, there are patterns everywhere. There's the days of the week, there's our specials rotation, you know, there's patterns all over. So it's having them recognize them also in numbers and in geometric figures that they see. So not only are there then patterns with shapes and symbols, but there's patterns with numbers, but there's different kinds of patterns. And we've mostly been focusing on repeating patterns and growing or shrinking patterns. So a repeating pattern, where I'll show you a few examples, there is a core that keeps getting repeated over and over again. And then with a growing or shrinking pattern, things are either increasing or decreasing. So we will look here at that. So let's start with these geometric patterns. So this here is considered a repeating pattern because here we see circle, square, triangle, circle, square, triangle. So we can say, oh, next is going to be circle, square, triangle. Over and over again, we see circle, square, triangle happening. And this right here in a repeating pattern, there's a core. This is considered our core. And the core is just, again, what keeps getting repeated. So it has a core. And so you can then use the core to help you predict what is going to come next, circle, triangle, or circle, square, triangle. And you can even use the core to predict way out in advance and say, what would the 18th be? Well, since this is getting repeated, I can actually stay here and go, well, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The 18th term, these are each a different term. The 18th term would be a triangle, and so I use the core to do that. Looking at these two geometric patterns, these are not repeating patterns. I don't see something happening over and over again. I actually see, it's kind of like shrinking, because each piece is getting smaller, or you could look at it as growing because more pieces are showing up. But what you notice is I went from one whole circle to now it's divided into two, and now these halves are divided again. So everything keeps getting divided into halves. So I went from 1 to 2 to 4, and then this is 8. So this had 2, this had 4, now this has 8, and if I drew it out, and it's kind of hard to see, but if I took my eighths and then I divided them, it's kind of hard to draw. You can't see that very well with my big marker, but that would be 16. Okay, so you can actually also attach a number to some geometric patterns. It's doubling the number of pieces that there are. So you can then predict again, the next one would be, there would be 32 pieces. So even though there's a geometric pattern, you can also sometimes attach a number to it. Here we have one more growing pattern. So here we have 1 square, and then we have 4, and then we have 9. So, we have 1, 4, and 9. Well, what else do we notice? We have a 1 by 1. We have a 2 by 2. Oh, here we have a 3 by 3. So I bet the next term would be a 4 by 4. And then the next one a 5 by 5. So you could use that to kind of predict, oh, I bet the 8th term would be an 8 by 8 square array there, okay? So predicting, thinking about what would happen further on because you've noticed a pattern. Moving over to numerical patterns here, you won't really see repeating. I mean, you could do that, but in 4th grade, we're not seeing that. Repeating would be seeing 1, 2, 3, 1, 2, 3, 1, 2, 3, you know, and I think we're kind of beyond that. They're not really seeing much of this. We're looking more at some of these kinds of geometric patterns. So with numerical, we're more looking at what operation is happening to these numbers. And you see numerical patterns in when people are doing data and statistics. So there's a real world implication there with patterns. They got to notice what's happening to these numbers so that they can make decisions, so that's further along in adulthood where patterns are coming into play. So with numerical here, what we want to see is, what do I need to do to get from number to number here? Well, if I do 2 and 5, well, I had to do a +3. And to get from 5 to 8, 5, 6, 7, 8, oh, that's +3 again. I think I might be seeing something. 8, 9, 10, 11. I think this is a +3 pattern. So I could predict next would be 14 plus 3 would be 17. So the rule is, here is a +3 pattern, because to get from number to number, I needed to add 3. Looking here, okay, so I had to do +1, and then I had to do +2. Well, that's not like that. Here I'm doing +3. It looks here that I'm increasing my addition by 1. So I bet the next one is going to be a +4, so that would be 11. And then I would do a +5. So my pattern here, or my rule here is, to get from number to number, I increase my addition by 1. And then looking down here, okay, so to go from 8 to 5, I actually had to subtract 3. But then to go from 5 to 10, I had to add 5. Okay, then I had to go from 10 to 7. Well, that's subtracting 3. So I see a similarity here, but I'm not seeing where this +5 fits in. So let me go more. Maybe this will be +5. Well, this is actually +7. I feel like the -3 should be there, but this here, let me see if there's a different relationship to these numbers, because the +5 and the +7 don't really follow a rule. So, well, 5 and 10 is a +5, but it's also 5 times 2 is 10. I wonder if that could work here. 7 times 2 is 14. So the rule here is subtract 3, multiply by 2. Subtract 3, multiply by 2. So I'm going to take that away. That didn't work, but here I would subtract 3. So 14 minus 3 would be 11. And then when I multiply, so that was my -3. Then if I multiply by 2, 11 times 2, that's 22. So as you can see here, there's so many different patterns you could do. And that can be the same thing over and over again, or the rule can change a little bit, or you can have 2 operations to get you from number to number, okay? So these are just some examples, and there's so many ways you could practice this at home with your 4th grader, doing geometric or numerical, doing repeating, growing, or shrinking, having them attach numbers to numerical ones, and just noticing patterns around them when it's happening. So use these ideas, use these vocabulary words when you are practicing patterns or pointing out patterns to your 4th grader.